广才，非志无以可学。
Assalamualaikum and a very good day to everyone. We are from S34 Group 4 and today we will be presenting about population of China, specifically about growth problem. This is our group member, that is Siti Rahayu, Nur Umaira, Alia Farhana, Aileen and myself, Muhammad Amirul. So for this task, we are focusing on population growth in China using the Malthusian model. This model, introduced by Thomas Malthus in 1798, explains how population grows at a rate that is proportional to its current size. The country's development, environment, and quality of life are all closely linked to its population trends. The Malthusian model is written as dp over dt equal to kp, where p is the population, t is time in years, and k is the growth rate. This helps us understand how population might change over time and why it matters.
Next, we are going to look into the table of data. We also plot a graph of actual human population in China from 2000 to 2019. The graph shows an increase in the number of population in China, although there is a slight fluctuation compared to the previous year.
Next, we will be looking into our solution of growth problem using application of the first order differential equation. First of all, we will let P equals to the number of population present at time t, since the rate of growth is proportional to the number of population P. Next, we will times the equation with 1 over P and move the dt to the other side, where we will get the equation 1 over P equals to k dt. And this is the step 1, where we will integrate both sides. We will get the general solution. And using the initial condition t equals to 0 at year 2000, we managed to find the A. Next, by using t equals to 1 at year 2001, we are managed to find the constant. Now, we obtain a particular solutions of p equals to 12695811775 exponent 0.00718 t. So, based on the calculated values, we are managed to construct an exponential graph of particular solution.
Next, this is the graph of the population versus time graph of the population in China from the year 2000 to 2019. As we can see, the green dots represent the actual population values that we gathered from our data, and the blue line represents our particular solution.
It can be predicted that the population of China will keep increasing in the future. By using the particular solution, we can estimate the past and future populations based on our data and the particular solution that we have calculated. For the past value, we use in the year 1991, which we use t equals to -9, and we got the value 1190135,377. For the future value, we use t equals to 24 and we got the value of 150,833,6009.
Let's take a look at the accuracy of our model by calculating the percentage error between the actual value and the particular solution. To calculate the percentage error, we use the formula actual value minus particular solution over actual value and we times with 100%. We got the percentage error is 1.65%. For the future value, we got the percentage error 6.27%.
Now, let's move to the discussion.
Are the values calculated from the particular solution accurate with the actual values? So as we can see from the previous graph, we can see that there is a slightly difference in the values calculated from the particular solution in comparison to the actual values. For instance, based on the data obtained from worldometers, China's population during 2015 was 1.3 billion, while the data obtained from the Malthusian model is 1.4 billion. The values from a particular solution appeared to be larger compared to the actual values.
Why is there a difference between the actual values and values calculated from particular solution?
Alright, the difference occurs because the Malthusian model exhibits an idealized, which is growing exponentially model, excluding realistic, unpredictable factors that might affect the growth rate. Thus, the graph of particular solution will appear to be growing smoothly in a fixed manner, while the actual graph of population in China will show fluctuations due to economical factors, pandemics, and changing policies. The Malthusian model does not consider any external factors such as environmental constraints that will naturally affect the growth rate. The value also solely depends on the growth constant, which is k. If the growth constant is slightly far off, the model will consistently predict values that gradually become distant from the actual values, where in this case, a higher values is predicted.
Moving on, what has affected the population in the past? So, during the 19th to the 20th centuries, China had a one-child policy that aimed to slow the growth of population. When China has an extended period of peace, the population swells rapidly. So, what are the key factors of China's population growth? First of all, urbanization and economic growth. Rapid economic growth in China in the late 20th century improved living standards, which often correlates with higher birth rates and in-migration. Moreover, the expansion of cultivated lands contribute to a higher crop yield and greater food supply, further supporting the growth of larger population.
What might affect the population in the future? China population dynamics are influenced by numerous factors, mainly economic and social, as one of the major economic powerhouse and leading exporters. China has a rather stable and growing economy. With this advantage, the government of China can offer many policies that support the growth of the population, such as improving health service. With improved and advanced healthcare, life expectancy will continue to rise. Despite everything, studies projected that China population is beginning to experience absolute decline due to the decreasing birth rate and aging population. This demographic shift is expected to significantly affect the growth rate.
So that's all for task 1. In essence, we had successfully obtained a particular solution by applying the first order differential equation. We managed to construct a model that is based on the particular solution at a given time and compare it to the actual China's population model. The model was tested with predicting the past and future population of China. All in all, this test successfully demonstrates the effectiveness of mathematical method to predict and address real-world matters. With a better vision into the future, many initiatives can be implemented to improve the quality of living. However, this task also emphasizes the constraint we may face by relying solely on mathematical method. Realistically, the occurrence of random events in this world is impossible to predict. Hopefully, with advancement of technology, this prediction can be more accurate and flexible in the future.
The Newton-Raphson method is an interactive numerical technique used to find approximate solution to equation of the form f(x) equal to 0. It is one of the most efficient methods for finding roots of real value function. The equation has a root at x between -0.5 and -1. Use Newton-Raphson method to estimate the root correct to 5 decimal places. First of all, we need to differentiate the equation to apply in Newton-Raphson formula.
As you can see, there are 5 columns, which is n, iteration number, x, the current approximation, the function value, the derivative value, and the Newton-Raphson formula. For fx, f prime, and the Newton-Raphson formula, we already inserted the formula for each column, as you can see here. By doing so, we will get the automated results. As you can see here, after the 11th iteration, the value of x becomes constant. Therefore, we will get our value, which is approximated to -0.94112.
So next, we let x equal to -1. As we can see here, after 4 iterations, The value again stabilized at x approximate negative 0.94112. This confirms the reliability of the method across different starting value within the interval. Based on this constructed graph, we find that the x-intercept is negative 0.94112. This indicates that our estimated value of x is correct.
That's all from us. Thank you.